I'm not a scientist, but I have a feeling that when atoms are energized, that is how they behave under the microscope.
Hello, welcome to Solution Prime TV, and today we are going to talk about amount of substances, that is chemistry. After watching this video, you are done with the amount of a substance, mole concept. Anything, any question on the mole concept, you have to understand. This video is not going to be short videos. It's a full video, long video. Where you are done watching the video, you must be able to solve questions under mole concept. Okay, so amount of substance and the mole. The mole here basically is the unit of amount of substance. Yes, and we are going to talk about atoms, molecules, and ions. These are the entities we are going to talk about. When we talk about amount of substance, then we are dealing with the number of atoms or molecules or ions present in that particular substances, or the what do you call it, the matter. Yes, you know the matter is anything that has weight and can occupy space, and anything that has mass and can occupy space has atoms, molecules, and ions present in them. So this is what you are going to do in chemistry. So you are going to solve more questions, do calculations, and I will explain the mole concept for you to understand. Okay, so this is mole. What is mole? It is the amount of substance which contains as many particles as there are carbon atoms in 12 grams of carbon-12 isotopes. So that is the amount of substance we are talking here, and it contains the many particles, as I said, the atoms, molecules, and ions. Okay, so that is that. So why are we using carbon-12? Why are we using carbon-12? Why are we using carbon-12 isotopes? Because we have a lot of elements out there, but our focus, we use, or the scientists who did or contributed to the development of mole, or the concept of mole, uses carbon-12. Why? At first, according to history or scientific history, they used oxygen to in the calculation, but it was difficult in solving the problem. So they decided to choose carbon-12, because carbon-12 element is stable. Yeah, is stable. For oxygen, it was not stable. So carbon-12 is stable. That is why they use carbon-12, 12 grams of carbon-12. So using 12 grams of carbon-12, they were able to solve the problem, and we have the concept mole. Okay, so the concept of the mole, what are we learning more? The real application of mole. You see, pharmaceutical, those who do drugs, and chemical engineers who do that, they use the mole concept. They use mole concept to calculate the number of particles or molecules that a particular medicine must contain. For example, you see, after doing the medicine, they will tell you take 2 drugs in the morning, maybe in the evening, or why are they not telling you to take 3? Because when you take overdose, it's going to have effect on you. That is how. So they measure the drugs using the mole concept, so that they will know the quantity of molecules, or the quantity of atoms that medicine must contain, in order to, when you take in, it will be able to fight against the disease, and you are able to survive. Okay, so that is that. Let's move to the second one. The particles which are elementary units. That is the particle I was talking about. I said it. The particles which are elementary units or particulate entities, that is the same thing of matter, like I said, can be atoms, molecules, ions, and electrons. And over here, atoms, when you consider atoms, there's a presence of electrons in atoms, so no problem. Okay, and the mole concept, we need to talk about one of the chemists called Avogadro. So he brought a constant in terms of the mole that will help us to solve the problem. Yeah, so according to him, he did research about it to bring us a specific constant, and it entails a lot. That is Avogadro's constant. They can ask you to define as a chemistry student or inter-science student, because mole concept is also under inter-science. Yes, it is defined as the number of particles in a mole of a substance. That is Avogadro's constant. The number of particles in a mole of a substance. So the number of particles, that is it. Molecules, ions, and electrons. Okay, Avogadro's constant L is equal to 6.02 times 10 raised to the power 23 entities per mole. Yes, it's based on the formula. Entities per mole is based on the formula. That is the formula we are going to talk about, and I will explain it to you. But most of the times in calculation, they bring 6.02 times 10 raised to the power 23 mole per. That is the constant. So you have, instead of this, you are going to have L is equal to 6.02 times 10 raised to the power 23 mole per. And you'll be seeing it in questions. Yes. For example, I have it here, mole per. Okay. So formula that we are going to use, you see, this topic is a mole concept. And we are going to talk about, you see, we have a lot of formulas under mole concept. This is one of them. That one, it involves the number of entities and Avogadro's constant. We also have other formula in terms of molar mass and mass. We also move to that, and we also solve questions for you to get understanding. But this is the first formula we want to, in terms of when they give you number of entities, Avogadro's constant, and number of moles. This is a matter of change of subjects. If you want n, you divide both sides by L, so that L will cancel L, and you get n over capital N over L is equal to n. If you want L, most of the times Avogadro's constant they will not ask you to find Avogadro's constant, because it's always give you, it's a constant, so it doesn't, okay, so this is the formula. N is the number of entities. What are the entities? Entities, we said they are the molecules, atoms, ions, and electrons. These are the entities you are going to see. Then small n is the amount of substance in mole. The amount of substance in mole. Then the L, I've talked about it. Avogadro's constant. Okay. So these are the questions you are going to solve using the formula. So pay attention very carefully and follow this concept. It's easy. More concept is easy. You see, we have qualitative analysis and quantitative analysis in chemistry, and you see, mole is one of them. And mole concept, when it comes to chemistry practical, mole concept is part, and we have one formula that we are going to use in terms of chemistry practicals, and we will do that under mole. So when you're able to watch this, you are done. Anything about mole, you should be able to understand. Okay, our first question. 1. Calculate the number of molecules in 0.2 mole of oxygen. We have given the Avogadro's constant 6.02 times 10 to the power 23 mole per. Okay, so let me explain. Over here, we have the unit to be mole per, but here it is entities per mole. That is the reason. You see, per the formula here, if you want to make L the subject, you divide both sides by n over n, and you're going to have capital N over n is equal to L. And what is the unit of the number of entities? And we said the number of entities are the atoms, molecules, and ions. These are the number of entities. So entities over mol. And you see, we are going to have L is equal to entities over N, which is mole. Yeah, so we are going to have entities per mole. That is it. So the reason why we have that is it, based on the formula. But most of the times we use mole per, so it's accepted. Okay. Okay, let's move on and let's finish this question. This is our first question that we are going to solve. Calculate the number of molecules in 0.2 mole of oxygen. So over here, you see, there's a difference between molecules, ions, and atoms. So when the question is asking for atoms, you know how to calculate for your mole. When the question is asking for molecules, you have to know how to calculate for your mole. But over here, we know the molecules are atoms of the same element or different elements chemically combined. So if you consider compound, definition of compound falls under molecules. Yes, because H2O2, Cl2 are all molecules, but these are not compound. Why? Because per the definition of compound is defined as chemical combination of two or more different elements. So CaCl2, that is a compound. H2O, that is a compound. Do you get it? But this is also a molecule, because per the definition of molecules are a group of atoms of the same element. So these are the same elements, and these are gases. All different elements chemically combined. So if we see that this is a compound, this is a molecule, this is also a molecule. So compound falls under molecule. That is what you see, learning and studying chemistry, you realize that it's true. So you can also check. This is what I think based on the definitions you'll be giving. That is the real definition for compound and real definition of molecules. Based on that, I realize that compound is under molecules. Okay, so let's solve the questions and move on. Calculate the number of molecules in 0.2 mole of oxygen. Okay, so they are asking us to find for N, and we know that the number of molecules in this is the same thing. So our mole is what? 0.2 mole. Okay, we are asked to find this. Always we're given the Avogadro's constant. So our N, straightforward, N is equal to small n times L. So N is 0.2 mole. If you like, you can introduce the mole, or you can ignore the units. There we have 6.0 2 times 10 raised to the power 23 mole per. So you do your calculations. Let's see. You can punch it on the calculator to get your answer. Okay, so you're going to have 1.204 times 10 raised to the power 23. We are talking about number of entities. So we are asked to find what? Molecules of oxygen. So you can say molecules. You can write that's the unit for the number of entities, molecules, or molecules of oxygen. So I did some calculations. When you punch it on the calculator, you are not getting this, no problem. You check your answer very well, or I'm the one making a mistake here. Okay, so let's go to the second question. That's question 1. Question 2. How many atoms are there in 0.3 moles of sodium? We know that for sodium, anytime you have sodium is one element, it's one atom. So the reason why I'm talking about atoms and I'm talking about molecules in a different way, there will be a set of questions. You understand, this one is a raw question because sodium is only one atom. So the mole is going to be 0.3. But when we have three sodium in a compound like this, three maybe compound like this, N2SO maybe 4, something like this. Over here, the mole like 0.3, the mole is not going to be 0.3. The mole is going to be 2 times 0.3. Take note of that. We solve questions and you understand. But over here, the atoms there in sodium is, we know that it's Na. Yes, it's Na. It's one atom. So the number of atoms, the mole is going to be the same. So we have our N to be equal to how many atoms? So we are calculating for capital N, NL. So 0.3 times Avogadro's constant 6.02 2 times 10 raised to the power 23. If you like, you can just ignore the unit when you are done. When solving it, when you are done solving it, you indicate it because number of entity is the unit for a number of entities, molecules, atoms, ions, and electrons. So after the calculations, let me check. You can use calculator like so we get 1.806 times 10 raised to the power 23 atoms. Atoms of what? Atoms of sodium, or you can leave your answer atoms. Okay, so that is it. That is our first question. We are going to solve more questions so that you get more understanding. You get more understanding. Okay, let's move on to set of questions. Um, let me clean this side. Okay, so this is we have three questions we are going to we are about to solve. We are about to solve. Okay, so the first one, calculate the amount of oxygen of a gas in a moles of 1.505 times 10 raised to the power 23 molecules of the gas. So it's dealing with molecules. So the same thing, the moles you are going to get is the same. The moles you are going to get is the same. So calculate the amount of, we are asked to calculate for N. Okay, so we know that our N is equal to small n capital L. So this implies that change of subject, making N the subject, you are going to have N over L. That is it. How do you make this one the subject? We want N to stand alone. So you divide both sides by L, both sides by L. This will cancel the, so you are going to have N is equal to capital N over L. Once N over L is equal to N, this implies N is also equal to capital N over L. Okay. So we have 1.505 times 10 raised to the power 23 molecules. So that is the number of entity. The unit is telling us 1.505 times 10 raised to the power 23 divided by the Avogadro's constant, which is 6.02 times 10 raised to the power 23. And to have 0.25 mole. That is that. That is that. Let's consider the question number 4, and that is question number 3. Let's consider question number 4. Let me solve question number 4 here. So question number 4, calculate the number of atoms of oxygen in 0.2 mole of oxygen. So we are asked to calculate for this. We know Avogadro's constant. We know N to be 0.2 mole, 0.2 or 0.20 mole of oxygen. That is the problem. You see, 0.2 mole of oxygen. Oxygen naturally exists as a gas. Oxygen is not, we don't have oxygen like this in nature. Oxygen is like this, O2. So naturally, oxygen is a molecule. It's a molecule. Oxygen exists as a gas. So sometimes they will give you oxygen gas. Yes, they will give you oxygen gas. Or when they are talking about oxygen, oxygen exists as, most of the time they will tell you oxygen gas like this. But this, we are talking about oxygen, and oxygen exists as a gas in nature. So over here, this is 0.2 mole of oxygen, what, gas. But they are telling us to calculate for the atoms of oxygen. So when, and you know, this is the oxygen atom. So this is a gas, but number of atoms in this is 2. Oxygen and another oxygen, making 2 atoms of oxygen. So over here we are going to have N of O2 is equal to the mole. We are not going to use this mole. We are going to use this one. We are going to have 2 moles, which is 2 times 0.2 or 0.20 plus 0.20, making 0.4 mole. That is the new mole that we have, because they are telling us to calculate the number of atoms of oxygen in 0.20 mole of oxygen gas. Oxygen exists as gas. So in chemistry, what you have to do is to study the atom very carefully. If you don't know the atom, for this question 5.2, we will solve it and you will see how we are going to get the answer. Okay, let's solve that. Okay, so question number 5, calculate the number of atoms of hydrogen in 0.2 mole of ammonia. So first of all, you have to know ammonia compound. If you don't know the compound, you can't solve this question. So ammonia, chemical compound for ammonia is NH3. So that is ammonia, NH3. But when you have ammonium, then the compound is NH4. So you have to know the differences. You see, based on the question, we're not giving the chemical formula for ammonia. So if you don't know the chemical formula for ammonia, then you can't solve this question. Okay, let's move on. We're asked to calculate the number of what? Entities. The number of entities. Okay, this one. Okay, yes. We'll calculate the number of atoms. So we didn't finish. Number of entities. We didn't finish. After calculating for the mole, we know that our N is equal to capital N. We are asked to calculate for N. So our N is equal to small n, capital L. So we have 0.4 times 6.02 times 10 raised to the power 23. 23. Don't bring the unit. If you are bringing the unit, make sure you bring all the units. And we are going to have 2.408 times 10 raised to the power 23 what? Atoms of oxygen. Atoms of oxygen. Okay, let's go back to this. So that is the question 5. So over here we have L. We are asked to calculate for the N. L is already given. We know Avogadro's constant. So we need to calculate for the number N, the small n, so that we can solve capital N. So hydrogen, this we are asked to calculate the number of atoms. If we are asked to calculate for the molecules, then we are going to have the same 0.2 mole. So 0.2 mole, when you have 0.2 mole, it's for the molecules. If they are telling us to calculate for the molecules, then we are going to use the same mole. But for the atoms, no. You have to calculate for the number of atoms in that compound. So assuming we are asked to calculate the number of molecules of hydrogen, like we are going to use 0.3 because hydrogen, this is a molecule, so the molecule will be 0.2 mole. But if they are talking about atoms, then we need to calculate the individual atom, number of atoms in the compound. So that is that. You need to take note of this. So how many atoms of hydrogen here? 3. So we are going to have our mole to be N like NH3, which is equal to 3 times the mole of ammonia. We know that the mole of ammonia is 0.2 mole. But that is it. If you want to know the mole of hydrogen combining with nitrogen to form this ammonia compound, it's going to be 3 times of the mole. So 0.2, which is 0.6 mole. If they ask you to calculate for the mole of nitrogen in ammonia, it's the same thing, 0.2, because nitrogen is how many nitrogen in the compound? 1. So 1 times 0.2 mole. So you are going to have the same thing. We are going to have the same thing. Okay, so right now this is our new mole of hydrogen, number of hydrogen atoms. If we are asked to calculate for the molecules, then it is 0.2 because the molecule here, assume that hydrogen H3 is a molecule, so it's going to be 1 mole. Like that is it. This is a molecule, so it's 1, the only one that we can see. So we have 0.2. If you are talking about atoms in it, then atoms is 3. Okay, so we'll have n to be equal to small n capital L. So we have n to be 0.6 times Avogadro's constant, which is 6.02 times 10 to the power 23. After solving it, you include your unit. You are going to have 3.612 times 10 raised to the power 23, 23 atoms of hydrogen. Atoms of hydrogen. Atoms of hydrogen. So that is the answer. This is a cool question. So you take note of that. It's very important. Atoms, molecules, and that's the difference. The main difference. If you don't take care, you confused. Since we are telling us to calculate for the atoms of hydrogen, you use 0.2 mole, which is wrong. If you use 0.2 mole for the hydrogen in the ammonia, then you are wrong. You are wrong. For the molecule, it's the same thing. For molecule, the mole doesn't change. But when you talk about atoms present, you need to check the number of atoms in it. Then you do your calculation. That is how you solve this problem. So we are going to move to the next formula, which is molar mass. Molar mass. Okay, so we are going to talk about molar mass, molar mass 2. And you see, there are different kinds of questions 1, 2, 3, 4, 5. After solving all these questions, you will really understand molar mass. Okay, what is molar mass? It is the mass of 1 mole of a substance. Any mass of 1 mole of a substance is referred to as molar mass, and it has a symbol capital M. Its units is gram per mole. That or this the division here based on math calculations is like the G over mole, and you are going to have G times 1 over mole. So in indices you are going to have G, and this one is going to 1 over mole is the same as mole minus 1. So that is it. So okay, formula, we have mole is equal to mass over N, mass over the mole, where M is the molar mass, M, small m is the mass, and we are going to consider this unit grams. And the mole concept, you are not going to use kilogram or milligram. No, our focus will be on grams, and we know N already to be mole. Okay, so for the first question, 1. Calculate the mass of 0.2 mole of magnesium atoms. And we have 2 ways of calculating for the molar mass. When you see this symbol, which is the magnesium, it has 24. So this 24 represents the molar mass of magnesium. Yes, they can ask you to calculate for the molar mass using the formula or using the normal calculation. So I'm going to teach the two so that you understand, because without knowing the two, you some questions you can't solve. Okay, so the first question, formula, molar mass is equal to mass over N. We are asked to calculate for the mass. You just make M the subject. So M is equal to capital M N. That is the molar mass. What do you have to do? You do cross multiplication. This time that 1 times this is M, and M times N is M, capital M times N. Molar mass for magnesium is 24 times a mass. We are given the mass to be 0.2, sorry, the mole to be 0.2. So we have 0.2. So we are going to have 4.8, yes, 4.8 grams, 4.8 grams. So we are going to use grams. In mole concept, we use grams. We don't consider the other units. In physics, most of the times our mass is in kilogram, but in mole concept in chemistry, we use grams. So take note of that. That is our first question. Question 2. Calculate molar mass of 0.2 mole of 0.2 mole of carbon 4 oxide, which has a mass of 11 grams. Okay, carbon 4 oxide is the same as carbon dioxide, carbon 4 oxide. So carbon 4 oxide is CO2. That is carbon dioxide. By IUPAC name is carbon 4 oxide. CO is carbon monoxide, but the IUPAC name is carbon 2 oxide. So we're giving the mass. Giving our mass to be 11 grams, and we have our mole to be 0.2, and we are asked to calculate for the molar mass. So molar mass is equal to mass over N. So we have our mass to be 11. If you are bringing the unit, you can choose to bring it. Then mole to be 0.2 mole. Okay. You can also ignore the unit like this. After that, you introduce the unit for the quantity you are solving for. So this one, you are going to have 44 grams, because 11 times 11 divided by 2 over 10, which is 11 times 10 over 2. Okay, so 11 times 5. Sorry. So we are going to have 55 grams. 55 grams. So that is it. Easy question. Okay, so let's move to the second question. The third question, question number 3. Calculate the amount of oxygen. So you are calculating for N in moles of 8 grams. So we know that our mass is equal to 8 grams of oxygen. Okay, so the amount of oxygen, which is small n, and given this, basically once you are talking about oxygen, they have to indicate the molar mass of oxygen. So oxygen is equal to what? The mass number for oxygen is 16. Okay, it's 16. So this means that our molar mass, if they didn't indicate, take note, the mass of oxygen is 16. This one is the mass, but over here is only one element, so it's the same as the molar mass. This one is the same as the molar mass. Okay, so over here we are dealing with oxygen gas. So O2 will be equal to, we are not going to have 16. We are going to have oxygen plus oxygen, because the oxygen here is 2. Anytime they give you compound to calculate for the molar mass, for example, NaCl, they will give you the mass of this. So the mass of sodium is maybe 23, and the mass of chlorine is 35.5. So when they ask you to calculate for the molar mass of this, it's going to be the individual mass of the atom. So molar mass of, assuming molar mass of NaCl, we are going to have 23 plus 35.5. And if you assuming that we have Na to be 2, then we are not going to have, the molar mass is going to be Na2Cl, which is 2 times 23, 23 plus 35.5. This is how we calculate for the molar mass in terms of when the compound is given, if we are not using the formula and they are telling us to calculate for the molar mass of the compound. This is how we do it. So we have to using the formula like this, or using what do you call it, using this. Okay, so oxygen, because they are referring to oxygen gas, we are going to have something like this. So we will have 2 times the mass of oxygen, which is 16. So you are going to have 2 times 16, which is 32 what molar mass, grams per mole, or that is accepted, the unit. You are asked to calculate for the amount. So molar mass is equal to mass over N. You make N the subject. We make N the subject. We're going to have mass over the molar mass. So we have our mass 8 over molar mass is what we've calculated for it, which is 32. So when you do the calculation, you are going to get 0.25 mole. So you can punch it on the calculator to verify. Okay, so that is that. Let's move to the question number 4. Question number 4. Question number 4. Question number 4. What mass of sodium is contained in 5 grams of sodium carbonate? Yes, we are asked to find the mass. We are asked to find the mass of sodium, which is Na sodium. We are asked to find the mass of sodium in what? Na2CO3. How? Given the mass of the individual element, and this one, you can't go forward by solving the mass of sodium. This grams 50, the 5 grams here is for the sodium. So what you have to do is to calculate for the molar mass of sodium carbonate. The mass of Na2CO3 and the substrate 1,1. If you don't want to use it straightforward, use your mass. Okay. So it's equal to 5 grams. This mass is different from this mass. This is mass of sodium. We are asked to find the mass of sodium, not the mass of sodium carbonate. Okay, so 5 grams. We can calculate for the molar mass for sodium carbonate. So let's try and find for the molar mass for sodium carbonate. Na2CO3 is equal to what? 2 times the sodium, and the sodium mass of the sodium is what? 23, plus carbon is what? 16. So you plus 16 individual element plus oxygen. Oxygen here is 3. So you are going to have 3 times the oxygen, which is 16. The 106 grams per mole. Don't forget the unit. So this is the molar mass for sodium carbonate. So once we have the mass of sodium carbonate and molar mass of the sodium carbonate, we can calculate for the mole of sodium carbonate. And based on the formula, this, you can make your N the subject. We make N the subject, you are going to get M over the molar mass. That is, you need to divide this over 1. So you are going to have M times N, which is Mn, is equal to 1 times M, which is M. Then you divide both sides by molar mass, both sides by molar mass. This one will cancel that. N is equal to mass over molar mass. So that is it. So we have our mass. Mass was given to be 5 all over the molar mass 106. And 5 over 106, we are going to get So 5 over 106, we're going to get 0.5 mole. You can check it out. Okay. So after getting your mole, anytime they ask you to calculate for the mass from a compound, then it means mole concept is involved. You have to find the mole first before you can solve the element in that compound. So once you've gotten this, how do you calculate for the mole of this? Because if you want to find the mass of the sodium, we have to get the molar mass of sodium. Molar mass of sodium. We know we're given molar mass of sodium is what? 23, right? So we need to find for the mole of sodium, then we find for the mass. Okay, so over here, let me clean this side. Okay, so over here, see, we have mole for sodium carbonate and it's 0.5. So the mole in sodium atom, it is 2 moles, like the previous video, the previous questions we solved. And when we are talking about atoms is different from molecules. So sodium is an atom. So sodium here is 2. So you are going to have new mole. So mole of sodium, Na2, not Na, because two atoms of sodium are what? Here. So which is going to be 2 times the mole of the compound, 0.5 mole. And this you are going to have 1 mole. That is it. So in the question, if you are asked to calculate for the oxygen, the mass of oxygen, then the mole here is going to be 3 times oxygen. And equation, you can even write it in equation, Na2CO3 reacting to produce sodium plus calcium carbonate. And over here, in order to balance it, we know that sodium is 2 here, sodium is 1, carbon is 1 here, carbon is 1, oxygen is 3, oxygen 3. So carbon is 1, 1, balance. Oxygen is 3, 3, balance. But sodium is 2. But sodium here, sodium is 2, sodium is what? 1. So you bring 2 here. In balancing of equation, you've taught. If you haven't been taught, then that is how we do it. So you see that sodium is going to have 2 moles times, that is what. So you can reduce this, you can use the formula or the equation to get your mole. When you get it, you get 2. You see the mole of this, which is 0.5 mole. Here carbon will be 0.5 mole. But here it will be 2 times 0.5 mole. And oxygen is going to be 3 times what? 0.5 mole. That is how we solve that. And if you are breaking this down, this is how you're going to get C plus oxygen. And oxygen, if I'm considering oxygen is 1, oxygen is 3, oxygen is 1. So you bring your 3. It's the same thing like I did. So that is how we deal with this. So this is our new mole of sodium in the compound. Okay, so you've gotten the mole. You can calculate for the molar mass of Na2. And it's going to be 2 times the 23. And this one is going to be 46 grams per mole. Okay, you've gotten that. So the mass of Na2 is equal to, per the formula, molar mass is equal to mass over N. So we are going to have Mn. We have our new mole 1 times 46, which is equal to 46 grams. So this type of question, mostly when they are telling you to find an atom or element in a compound, what you have to do is that probably they will give you the mass of the compound, the molar mass you can find from the individual atoms, because I told you we have 2 ways of solving the molar mass. You apply that concept and you solve for mole. Then you connect the mole with the element they are telling you to solve. For example, if it is oxygen, I told you it's going to be 3 times of oxygen. You check the number of atoms in that compound. If it is 10 times the mole of the compound. So this is how we solve that. Okay, question 5. Calculate the number of atoms in 18.5 grams of magnesium metal. The number of atoms in 18.5 grams of magnesium, 18.5 grams of magnesium metal. Number of atoms. So we are asked to calculate for N. Okay, and we're given the magnesium atom to be 24.3. The mass of magnesium metal or magnesium is 24.3. Okay, that is the molar mass. So since we have the molar mass for Mg is 24.3. 24.3. So it's going to be straight for 24.3 grams per mole. And we know mass. The mass is 18.5 grams. So we know this. We have to use the formula. Molar mass is equal to mass over N. So our N is equal to mass over molar mass. So we have 24.3 over 18.5. So you punch it, and you know when you get your answer, we are asked to find the number of entity. When you get your answer, then this is N times L. So we have getting your answer, which is 24.3 over 18.5. That is the N. You punch it on the calculator to get your answer. You multiply by the Avogadro's constant 6.02 times 10 raised to the power 23. Then you get your answer. Let's solve one question under the molar mass. Okay, cool question. The amount of sodium carbonate X hydrate. So if you calculate for the X and we get 5 is pentahydrate, sodium carbonate pentahydrate. If it is 4, tetrahydrate. If it is 6, hexahydrate. This is how we are going to we name the compound. It's a sodium carbonate attached with water. Okay. So the amount of, that is the mole, the amount of sodium carbonate X hydrate is 0.375 mole. What is the value of X if the mass of the compound is 107.25 grams? So 107.25 grams, that is the mass. Okay, so how do we calculate for the molar mass? We know that we have grams and we have mole for this compound. So we are calculating the molar mass for this compound. So the molar mass is equal to mass over the number of moles. So we will have 107.25 all divided by 0.375. When you punch this on the calculator, you are going to get 286 grams per mole. Don't forget the unit. So that is that. When I'm done, we also know that molar mass, how do we calculate for the molar mass? We have two ways of calculating for molar mass, using the formula or using the other one, which is molar mass for the compound is also equal to 2 times the compound, the mass of the atom. So the chlorine, we didn't include chlorine. Oxygen is 16, sodium is 23. Yeah, sodium is 23. Okay, so let's move on. So we have 2 times the sodium, which is 23, plus individual addition of individual element. Carbon is 16. I didn't include carbon. Carbon 16. So we have 16 plus, no, oh no, carbon is 12. Carbon is 12, sorry. Oxygen is 16. Carbon is 12. They will give it to you. Probably they will give it to you. 12 plus oxygen. Oxygen 3 times 16 plus X. I told you the X is attached to the compound water. And if it is 5, I told you, so this is a number multiplying the water. So we are going to have plus X into bracket hydrogen. I didn't include hydrogen. Hydrogen 2 is H equals 1. That is the mass of the hydrogen. Okay, so we have times 2 times 1, which is the same as 2. 2 times 1, hydrogen 2. So making 2 times 1 or 1 plus 1, which is 2. Plus another oxygen, which is 16. 16. Okay. But we know that our M is 2 aces. The same equation, this is equal to that. And we've calculated for this. So I'll introduce 2 aces is equal to 2 times this, which is 46 plus 12 plus 16 times 3, which is 48. 48 plus X into bracket 18. So straightforward, we are going to have 18x. So when you do your calculation, we are going to have 2 aces minus 46 minus 12 minus 48 is equal to 18x. We are going to have 180 is equal to 18x. Then you divide both sides by 18. So we have our x to be 10. So therefore, x to be 10. So that is that. So you can see there's no beard here. So this is not AI, it is real. Yes, I was doing it little by little so that you get the full video of more concepts, so that when you are learning, you get more insights. Okay, so today I will continue with molar volume. So I'll continue with the molar volume. For molar volume, the symbol is V, capital V, small m. That is molar volume. So what is molar volume? What is molar volume? It is the volume occupied by 1 mole of a gas at a fixed temperature and pressure. So that is mostly This formula are used in gases. They are used in gases, yes. So when you have a fixed temperature and pressure, then you can use this formula. You quote the formula, then you know how to use the formula. The second one, I've written the key point. At a standard temperature and pressure, that is STP. So always the question will be given at a standard temperature and pressure, STP. So when you see STP, then they are referring to standard temperature and pressure. The volume occupied by 1 mole of a gas is 22.4 dm3. That is decimeter cube. That is, it means that the molar volume is a fixed volume. Always it is 22.4 dm cube. So they will give it to you. If they didn't give it to you, you know it off head. You know, they can ask you 22.4 decimeter cube. So at the standard temperature over here, since we are dealing with standard temperature, the standard temperature is 273 Kelvin, 273 Kelvin. That's the Kelvin is the SI unit for temperature. Then standard pressure, we have 100 kilopascal, 100 kilopascal. And we know that the kilo here is 10 raised to the power 3. So if you want to do calculations here, let me so okay, if you want to do calculations here, this is the same as 100 times 10 raised to the power 3 PA. This is prefix. In physics, they taught you prefixes. Mega means 10 raised to the power 6. Kilo means 10 raised to the power 3. Giga means 10 raised to the power 12, and it follows. So if I do this, I'm going to get 100,000 Pascal. So that is it. This is the same as that, or 1 atmosphere, or you can say 1 atmospheric temperature. So that is that. So whenever you are dealing with molar volume, is we use this formula under gases. So when they are talking about molar volume, then you have to have your STP, that is standard temperature and pressure. So that is the formula. Molar volume is equal to V over N. So if you make N the subject, you are going to get V over Vm. When you make V the subject, you are going to get Vm times N. That is change of subject. So I have my first question here. When we are done, we will solve question. Bear in mind, after solving this question, this is easy. This is easy. Every question, it has the easier question, we have intermediate, and we have the difficult questions. This is what you are going to do. The easy questions, intermediate question, and hard questions. So the first question is easy. You are just using the formula to solve it. How do you go about it? We've talked about molar volume, and we know that the formula for the molar volume is Vm is equal to V over N. So once you've gotten this, where Vm is the what? Molar volume, V is the volume, new volume applied, and N is the amount of substances. Okay, so calculate the volume occupied by 0.25 mole of methane gas at STP. So I told you we do this in gases, and we have STP here at a constant, at a standard temperature and pressure. So that is it. Always Vm will be given. We know they are telling us to find V, so you'll be given the mole. So from this, that is our formula. From here, we know that Vm is equal to V over N. But if I make V the subject, I'm going to get N times Vm, which is the same as what? NVm. So it's the same thing. Okay, you can quote straightforward. You can quote that V is equal to N times Vm, no problem, without writing this and trying to make, because when you do this, you're not going to get any marks from that. Okay, it's the same thing. So our mole is 0.25 times Vm, which is 22.4 you do your calculations and 5.6 dm cube. You can punch it on the calculator or you can solve it using decimal multiplication. 25 times 224. When you are done, when you multiply, getting the answer, you count the number of decimal places 1, 2, 3. Then you run forward to get your answer, which is you're going to get 5.6 dm cube. So let's try another question. I'm going to write another question on the board, then you solve questions. Listen, you see, this question is easy, but the question that we are going to solve, they will give you molar mass. They can give you molar mass. They can give you mass, because we know that n is also equal to mass over molar mass. So before you can calculate for the volume, they have to give you mass, molar mass, so that you go and find. You see, we know that Vm is 22.4 dm cube. So what the question will ask you is that, and these are the questions that comes these are the questions that come in the exams. Yes, because they are not going to give you simple questions. This one will be maybe objects, but in exams, whether interscience, they can bring this interscience or chemistry. Yes, these are the questions they are going to bring. The next question that we are going to solve. So in order to get, you see, this one, the mole was given, but rather they will ask you to find V. Before you find V, you have to go and search for the mole. To get your mole, then you substitute in to get your answer. But before you get to the mole, they have to give you some what do you call it? Some ingredients. Some ingredient or something that will help you to solve for the mole. Like they will give you mass in the question, they will give you molar mass. The way maybe if they are not giving you the molar mass, they will give you something for you to know and find for your mole. Yes. Okay, let's solve it so that you get what I mean. Okay, there's a space here. Let me write it here. But let's solve easy questions. Another easy question so that you get the concept. Let's solve easy questions. Calculate the amount of carbon for oxide. So you can feel free and pause the video to try your hands on. Okay, this is how we are going to go about it. We are asked to calculate for the amount of carbon for oxide in 2.8 dm cube of the gas at STP. So we all know that Vm is always 2.4 dm cube. We're given the volume to be what? 2.8 dm cube. And we're asked to find the mole. So we know that Vm is equal to what? Volume over N. So straightforward, N is equal to V over Vm. We have our volume to be 2.8 divided by Vm, which is 22.4. 22.4. When you do your calculations, you are going to get 0.125 mole. you are going to get 0.125 mole. So that's it. So it's a matter of you making change of subject here. That is 2 questions. These 2 questions are cool questions. They are easy. So I'm moving on to the third question. Question 3. Okay. So question 3. Calculate the molar mass of 11 grams of a gaseous hydrocarbon which occupies a volume of 5.6 dm³ at STP. Okay, so from this we are asked to calculate for the molar mass, and we know that molar mass is equal to mass over n. Mass over n. So we're given the mass to be 11, but the number of moles is not given. But before you find for the molar mass, you have to go and find for the number of moles. And the number of moles here is given, we've been given the molar volume, we've been given the new volume. Do you get it? And since we have V and Vm, we can find the number of moles using that concept, which is the molar volume. Okay, so basically when you are starting you know that our V is equal to 5.6 dm³. We have Vm to be 22.4 dm³, and mass is given to be 11 grams. Okay, so Vm, we know that N is equal to V over Vm. Per our previous explanation, we know that N is equal to V over Vm. So V, which is 5.6 5.6 over 22.4. Okay, so when you punch it on the calculator, you will get your number of moles. 5.6 over 22.4, so mole. That is it. You can punch it on the calculator, or you can use this. When you punch it on the calculator, make sure you use 4 decimal places. Good. Okay, after getting this, we know that molar mass is equal to mass over what? Over n. Okay, so we have 11 all over 5.6 over 22.4. When you punch it on the calculator, you are going to get you are going to get 4.4. So when you punch it on the calculator, you are going to get 44 grams per mole. That is the unit for molar mass. So 44 grams per mole. That is a cool question. Let's solve a last question under molar volume. Then you move to the next topic. Okay, so that is our last question. A container holds 3.7 grams of dithyl ether, which is C2H5 into bracket 2O vapor. Calculate the number of molecules. You see, most of the questions you watch it and they are not going to solve difficult questions. They are going to solve only the surface question to you. But meanwhile, so you have some questions that are tough for you to understand. Okay, so that is why we are going through all this process, and when you watch this video you understand very well. Okay, so A, the number of moles of C2H5 bracket close 2O. This can be written as C2 times 2 H5 times 2. Then we have your O, which is C4 H10 O. This is the same as this. Okay, so the number of molecules of this compound, but in the question we were given our mass to be 3.7 grams. Okay, so since we have grams there and they are telling us to find a mole, I can using this formula. Vm is equal to V over N. I can't find the mole, although I have my Vm in the question, which is the molar volume, but my V was not given in the question. So there is no way I can use this formula to solve. But if I'm using molar mass is equal to mass over N, let's see this formula. I can solve this. See, because we'll be given the mass number for each element in the compound, so I can use that idea to find for the molar mass. Then I have my mass to be 3.7, so if I make N the subject, I can find the molar mass easy. Let me check these formulas too. I have my L here, that is 6.02 times 10 to the power 23 mole per. But I can't use this formula because the number of entity is not here. Even they are asking me the number of molecules, so they are asking me for find N. So there is no way I can use this formula and this formula to solve the first one, the number of moles. I can't. So this will be the correct formula to use. Okay, how do you calculate for the molar mass? You know the molar mass for this C2H520 is supposed to be subscript. You have to write it in the subscript, or if you like, you can write capital M is equal to, you know how to find for the molar mass. How do you find for the molar mass? You add the molar or the mass number for each of the elements. So I have carbon. Carbon is what? Carbon is 12. But carbon is 2 here. So it's going to be 12 times 2, or 12 plus 12. Plus, I have hydrogen here. Hydrogen is what? 1. So I'm going to have 1 times what? 5. Or 1 plus 1 plus 1 plus 1. Up to 5 times. Then, since I have something like this, it will be bracket close times 2. That is the key point, because this is going to multiply the molar mass of each of the elements. That is it. Then I'll have plus oxygen, and oxygen is what? 16. If you don't like in this way, that is that. So the 2 will multiply this, making 2 times 2, and you see 2 times 2 here. That is why I have 4. So if I'm using this, I'm going to get 12 times what? 4. Then this one, 2 will multiply this, making 10. So 10 times what? Hydrogen. How many hydrogen is 1? 1 times what 10. So it's the same concept. That is it. So if you are using this, cool. If you are using this, it's also accepted. But it is safe to use calculate in this form because this is what you've been given. But in order to break it down, to get to your answer, you can use this. Okay. So you do your calculation, 2 times this, you're going to get 12 into bracket 4 plus this time is that, which is 10. 10 times 1 is the same thing. Then we have R plus 6. When you punch it on the calculator, you are going to get 74 gram per mole. Yes, cool. Okay, we are done. So we can now find for our mole. Mole is equal to mass over molar mass. So we have our mass to be 3.7 all over our molar mass, which is 74. We're going to get 0.05 mole. So that is that. We are done with the first one. Let's go to B. B. The volume of the mole, the volume of the vapor at STP. So you know that Vm is equal to V over N. We've gotten our mole. So our V is equal to Vm N. So Vm always 22.4 times our mole, which is 0.05. So 24.4 times 0.05, 1.12 dm cube. That is it. Make sure your answer tally with this. When you punch it on the calculator, you're not getting this correctly, and you're not getting the day, means you are correct. Okay. So let's move to C. 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 The number of molecules of the compound present. That is number of entities. And we know the number of entities is equal to small n times L. So our n, we calculated for our n. Our n is 0.05 times L is the Avogadro's constant, 6.02 times 10 raised to the power 23. 3.01 times 10 raised to the power 22 molecules. Molecules is accepted, or molecules of C2H520. So that is that. We are done with molar volume. We are moving on to another topic. Okay. We are moving to Faraday constant. Faraday. Let's write something down. Sorry. Okay. So Faraday constant F, it is the total charge in coulombs carried by 1 mole of electrons. So that is the Faraday constant. Is what he was a scientist, or he was a chemist, he was a scientist who brought the idea, that is charge. He brought electric charge. So every electric charge is measured, or quantity of charge or electric charge is measured by coulomb. That is the SI unit for electric charge. And he discovered it, so we use his name as the unit, like Isaac Newton, who discovered force. So we use force, the SI unit for force is Newton. That is 50 Newton, 70 Newton. So 270 coulombs. That is electric charge. Then we are dealing with electric charge. So when we are dealing with the total charge in coulombs carried by 1 mole of electrons, the total charge carried by 1 mole of electrons. So in electron, you see, electron causes electricity. So that is, a charge is the flow of electrons. Yes, electricity is the flow of electrons. So the flow of charges causes electricity. Okay, so if we are dealing with the total charge in coulombs, that is the unit for electric charge. Yes, carried by 1 mole of every electron, then it is Faraday constant. Okay, so Faraday constant is 96,500 coulomb. 96,500 coulomb. And Faraday constant is also equal to the Avogadro's constant times the electric charge. That is it. This is called the electric charge. And if you are doing calculations, you will see that L is 6.02 times 10 to the power 23 times electric charge. Okay. And I've told you 1 Faraday is always 96,500. And 1 Faraday constant is the same as this. Okay. And when you do the calculations, this is also the same as 1 mole electron. 1 mole electron. So this means that Faraday's constant is equal to 96,500. Faraday's constant is the same, is also equal to 1 mole electron. One Faraday's constant is also equal to 6.02 times 10 to the power. So listen, what we are going to use is that 1 Faraday is equal to this, 1 Faraday is equal to this. These are the things that we are going to use. And also, we are going to talk about the quantity of charges and the Faraday constant once we are talking about charge. So quantity of charge is equal to current times time. So that is Q is equal to I times time. So if you want to do calculations, quantity of charge in terms of current and time, that is the formula. Q is equal to I times T. Also, the quantity of charge is also equal to N times F. That is the mole amount of substance times the Faraday constant. times the Faraday constant. So these are the things we are going to solve questions for you to get the concept very well. And you know what we are going to use, basically what we are going to use, the formulas we will use will be maybe 1 Faraday is equal to 96,500 coulomb. That is 1 Faraday is also equal to 1 mole electron, and the quantity of charge, which is equal to NF, and quantity of charge, which is equal to I times T, or IT. These are the formulas you are going to use under Faraday constant. And since 1 mole is equal to this, and 1 Faraday constant is equal to this, 1 Faraday constant is equal to this, I can also conclude that this is also equal to that. That is 96,500 coulomb is also equal to 1 mole electron. 1 mole electron, because they are all equal. If they are equal, it's like if A is equal to B and C is also equal to B, then I can conclude that A is also equal to what? C. That is that. They are all equal. So this is what we are going to solve. Let's try questions and see how it's going to be. Question 1. Calculate the total charge in coulombs carried by 3 mole electrons. Okay, let me write the question number 2. How many electrons carry a total charge of 193,000 coulomb? Then let me add the last question, then we are done. Calculate the time needed to pass 0.5 mole electron using current of 25 ampere. Okay. Calculate the total charge in coulombs carried by 3 mole electron. So this type of question, one thing you have to know is that we are calculating for the charge. Once you are calculating for the charge, the formula that we are going to use is this, because they are telling us to find for the charge. But we know from this, we know that 1 Faraday is equal to what? 1 mole electron. Yes, we know the 1 Faraday is equal to 1 mole electron. And this one, they are telling us to find for the Faraday the total charge. So this one is 3 mole electron. electron. And in a Faraday, the charge we don't know. You see, if 1 Faraday is equal to 1 mole of electrons, the 3 mole electron will be what? Will be 3 times F. Will be 3 times F. Because if this is 1F is equal to this, it means 1 times 96,500 coulomb is equal to 1 mole electron. That is it. 1F is equal to, that is why I told you that 96,500 is equal to 1 mole of electrons. So this is the same thing, and the 1F is the same like this. So instead of reusing this, is the same thing. You can use what I've written there. You see, so 96,500 coulomb is equal to 1 mole electron. And in 3 mole electron, then you don't know this. You can represent it with X or Y. But one thing you have to do, after representing it with X, you can do cross multiplication, or you can write it straightforward. The total charge. You know it. You know that this one is going to be 3 times 96,500. So this means this one you're going to get 3 times 96,500 what? Coulomb. So you multiply 3 by 96,500 to get your answer. So you're going to get 289,500 coulomb. So 289,500. So you point it on the calculator. This is what you are going to get. This is cool. Let's try the second one. Question number 2. For the question number 2, how many electrons carry a total charge? How many electrons? Then it means number of entities, number of electrons. Then they are telling us to find for N. Yes, they are telling how many electrons. So the number of entities. But we know that N is equal to small n times L. We know that Avogadro's constant is a constant. So we know that L is equal to 6.02 times 10 raised to the power 23 mole per. But we don't know N. So we have to go and search for N so that we can use this formula to guess the number of entity. But when we check the question, they've given us the total charge. Sorry. So the total charge, which is Q, is equal to 193,000 C. Which formula has number of amount of substance in it? N. So you can see we can use this. If we are using this, we know Q, that's quantity of charge. So Q, and we know Faraday constant. The 1 Faraday constant is always 96,500. So we can use this formula. So from Q is equal to NF, we know that our N is equal to Q over F. Okay. So Q 193,000 divided by F, which is 96,500. So when you punch it on the calculator, the answer you get, you include your mole. Okay. You include your mole. Or I want to use so this is my N. So if this is my N, right now I've gotten my mole. So N is equal to the mole. And the mole, what you got, you can place it here. I'm placing the whole of this, which is 193,000 divided by 960,500 times my L, Avogadro's constant, which is 6.02 times 10 raised to the power 23. So when you punch everything on the calculator based on what you get, when you get it, leave it. If it is long, if it is 5 decimal place and above, you leave your answer in 4 decimal place. You get the same thing. So the number of entity will be equal to 12.04 times 10 raised to the power 23. What entity are we talking about? Electrons. So that is that. It's the same thing. You see, the presentation, how you present your work is very important. Okay, so after writing everything, you can write it Q is equal to NF. Then you make N the subject, you solve it neatly, getting your mole. I told you that when you solve it, if it is 5 decimal place and above, leave it in 4 decimal place so you can approximate it, and using your own, you are going to get the same answer. This is the same as what you get. So that is that. It depends on the formula that you're going to use. Let me go to question number 3, then we are done with Faraday constant. Calculate the time needed to pass. So needed to pass 0.5 mole electrons using a current of 25 ampere. So from this, we know that our Q, we are asked to calculate for the time, which is T. But we're given the current I is equal to 25 ampere. That is the SI unit for current. But we're given mole. N is equal to 0.5 mole. Okay. But if you want to find time, we know that from Q to be IT, you can make T. Okay, so as you can see, it's a short video that I did. That is why you see I'm in a different clothes again. Yes. So we didn't finish this. I was solving this and I ended it. So I will continue with that. Calculate the time needed to pass 0.5. So we are given mole to be 0.5, amount of substance, which is in mole, to be 0.5. Current I is 25 ampere. Okay, and we are asked to calculate the time needed to pass 0.5 mole of electrons using this. But we know that quantity of charge is equal to I times what? T. But if I make T the subject, I'm going to get Q over I. So you're asked to find the time. Right now, I know my current, but I don't know the quantity of charge. There's no way I can solve time if I don't have my quantity of charge. But the quantity of charge also have another formula, which is Q is equal to NF. So I can use this one to find my quantity. After getting it, I can substitute into this, then I will get my answer. So we're given the mole to be 0.5. Then Coulomb's Faraday constant, we know that it is 65,000. 65,000. And we know that Faraday constant is 96,500. So quantity of charge, this times that, we are going to get 0.5 times that. You can punch it on the calculator and we will get 48,250 coulomb. That is the charge. There is no way you can't solve the question given. You see, per the question, you can see they've given you mole, current. So using this formula, we know that our time is equal to that. But you see, quantity of charge has another formula which is linked to the number of moles. Okay, so we all know Faraday 96,500. So that is our final answer. So I can substitute in the values. T will be equal to quantity of charge, which is 48,250 divided by the current, and the current 25. When you punch it on the calculator, we are going to have 1,000. We are going to get 1,930 seconds. So that's the final answer. 130 seconds. So that is the time. And you see, I told you this is measured in seconds, this is measured in seconds, this is measured in ampere. That is the unit. SI unit for current, ampere, SI unit for time, seconds. And we have our mole. That is the final answer. Okay. So that is that. We are moving on to another concept under mole concept. Another topic. We are moving on to another topic. So we are moving on to another topic which is under mole concept, or the amount of substance. Yes. So that is quantity of solid in a solution. We know that for every solution, we are done with this. For every solution, solution is equal to solute plus solvent under mixtures. So if you want to get solution, then you have to react solute plus solvent and you get example, salt. Salt is the solute. When you talk about solute is a substance, is the solid part of the substance, or is the substance that dissolve in a solvent. So always solvent is a liquid substances and the solute are the solid substances. Okay, and the solvent is a substance that dissolve a solid. So water will dissolve salt. Okay, so let me use solvent like water. So salt and water, I will get salt solution. Sugar plus water, this is mixtures. Yes, when I add them, I'm going to get a solution. So that is how a solution is formed. So the concentration of the solution is very important. You see, when you talk about, for example, if I have dilute acid and concentrated acid, the concentrated acid will corrode my body more than the diluted one. So that is, it is very important we take into the consideration. We take concentration. You get to consider concentration. It's very important. We need to take concentration into consideration. Yes. So under more concept, concentration is very important, because if you know the concentration of the substance, it is very important, because when you go out to go and buy any chemicals, it has its own concentration written on it. So when you bring it home and you want to, do any practical or react any chemicals with the chemicals that you went to buy, then you see it has its constant concentration or specific concentration when you go out to go and buy. So it is very important. Yes, if concentration is not important, like medicine that we see and others, it will be difficult. So concentration is very important. When you go to the drugstore, you go and buy maybe chemicals like medicine, liquid in the liquid form. Yes, when you take it, they will give you some specific concentration. You see, when you go and buy it, you see some concentration. They are different. That is it. So concentration is very important. It's very important. So quantity of solute in the solvent. Concentration can be expressed in several forms due to the measurement of the quantities of a solute and a solvent in a different unit. That is what it's trying to say. So you can measure it in any way depending on the solute and solvent. The solute is the solid part, that is the one that dissolves the solid. So the quantity that you will pick for the solute and the quantity that you will pick for the solvent, when you react, it will depend on the solute and the solvent. Yes, in solvent in the reaction. Okay, that is very important. So under the concentration, we have two types of concentration. We have mole concentration, which is called the molarity, and mass concentration, which is sometimes called the mass density. After this, after solving questions under this, calculation under this, we move to the second part, which is the mass concentration. But when we talk about mole concentration, what does it mean? Mole concentration, it is the amount of substance in moles dissolved in 1 dm cube of a solution. Yes, the amount of substance in moles dissolved in 1 dm cube of solution. Depending on the formula, you understand more better. And B, over here, sometimes in the question, they will give the volume in centimeters. So since per the formula, we are doing calculation in dm cube, that is decimeter cube. We are not doing it in centimeters cube. So if you are solving any question and you leave your answer, the volume, if they give the volume in centimeters cube, and you don't convert it to decimeter cube, and you solve it in centimeters cube, you are wrong. Everything is wrong because you have to convert it to dm cube because of the definition, amount of substance mole dissolved in 1 dm cube. That is dm cube. That's the unit here. Okay, it has a unit mole per dm cube, or this is the same thing. Just that the slash here, the division here, is telling you that in mathematics, this one, if you do the calculation, you are going to get dm exponent -1. It's like this. Mole over what? Dm, that is the unit per the formula. Yes. This is measured in mole. And this is measured in what? Dm cube. Dm cube. So this is mole times 1 over dm cube. Okay. Law of indices. When you have something like this, it's the same as a to the power -1. So I'm going to apply this method. Then I'm going to get d exponent 3 minus 1. And this will multiply the power. So I'm going to get mole dm minus 3. That is that. So this is the same as that. Okay. So the formula here, we are going to use two formulas here. The normal formula for the concentration. Every concentration formula is equal to N over V, where the N is the amount of substance. It is measured in mole, and V is the volume measured in dm cube. We also have another formula. M is equal to concentration times molar mass times the volume. I will prove to you the reason why we had this. So this one, I will prove to you for you to understand more. I'll prove to you. Okay, I'll show you how we are going to prove it. It's easy and cool. Okay, but before we start with the question, let me prove the second formula. Okay, for the first formula, concentration, mole concentration, you know that mole concentration is equal to N over V. Let me name it equation 1. But in our previous video, our previous discussion, we said that molar mass is equal to mass over N. Yes, that is that. Mass over N. We know that molar mass is equal to mass over N. So over here, I'm going to make N the subject. From this, when you make N the subject, you are going to get mass over molar mass. Mostly, if you have something like, you can interchange it, because this is cross multiplication. 1 times M, you are going to get M n times m, that is it. Like m times n, which is mn, 1 times m, which is m. You divide both side by what? Divide both side by m, both side by m. N is equal to mass over molar mass. So this one, you're not going to get anything from it. From this, if you make n the subject straightforward, you are free to go. That is that. So this is my equation 2. You see, this is the general formula for mole concentration. C is equal to N over V. Molar mass also, molar mass, I'm trying to prove M is equal to C times M times V. Small m is equal to C times capital M times V. Okay, so after getting this, what do you have to do? I'm going to substitute N into this. So like simultaneous equation, this is cool. If you haven't treated simultaneous equation, be cool, quote this formula, then you make your N the subject because you have knowledge about change of subjects. I've done that. After that, you can write putting equation 2 into equation 1. What it means is that I'm going to put this one into this. So the when if I see n, I can put mass over molar mass for there. So I'm going to get C is equal to mass over n. Then I have my bigger V that is accepted. This can also be written as mass over n divided by V. Yes, this is the same as that. Okay, so mass over n, when I change it to multiplication, I'm going to have 1 over V. Okay, so I have I'm going to get m times 1, which is m, over n times V, which is nV. Then I have my concentration, that is that. After getting your concentration, change of subject, this is over 1. So 1, I'm making m the subject, 1 times m, I'm going to have m, and C times n, oh sorry, I did a mistake here. It's supposed to be m over molar mass, m over molar mass, and this, I have my m, and this is also capital M, sorry for that. Okay, so this is also capital M. So after getting this, you do cross multiplication. 1 times m is m, and C times m times V is C m V. It's the same thing, multiplication. Okay, so this is how we prove for the second formula. You can also choose to, from here, equation 1 and equation 2, after writing this, you can also indicate that equation 1, you can make n the subject from here. We make n the subject, you can also substitute into this. So you can also write maybe this to be equation 2, and from equation 1, you can make n the subject. So we make n the subject, we're going to get CV. Then this is CV. Then you put in n equals CV into this. So if you put n equals CV into this, whenever you see n, you put CV, you are going to get the same thing. You can try on that and you will be on the right way. Okay, so we are done. First formula, second formula. So we are going to solve all the questions based on this formula. So I'll prove it to you. If you want to go through, you can pause it and go through. Okay, so the first question, find the molarity of a solution in which 0.5 mole of sodium hydroxide is dissolved in 100 centimeters cube of solution. So we are asked to find C. We know N is equal to 0.5 mole, and volume is 100 centimeters cube. So this we are going to get 100 divided by 1000, that is MB. Every 1 dm cube is equal to 1000 centimeters. Is 1000 centimeters. Yes, so we are going to divide by 1000. Okay, so 100 over 1000, we are going to get 0 point, that is, you check 1 2 3, 1 2 3, so 0.1 dm cube. Yes, anytime they give the volume in centimeters, you just have to divide by 1000. But if you are sending in unit conversion, if you are sending decimeter cube to centimeters cube, then you are going to multiply this by the 100, like this. If assuming there was 100 dm cube and you are sending it to centimeters cube, it's going to be 100 times what? That 1000, which is equal to 100,000 centimeters cube. That is it. But in this type of question, always it is over 1000 over 1000. If it is centimeters, then sending it to decimeter, you have to divide by 1000. Okay, so you know our formula, C is equal to N over V. So our N is 0.5 and we have our volume to be 0.1. So this we are going to get 5 mole per dm cube. The unit is very important. The unit is very important. That is that. So that's our final answer. Okay, question 1. Let's go to question 2. Question 2, let me clean this side and let's solve it. More concept is formula work. If you know the formula and you know the change of subject and you solve more questions, you'll be able to kill it. You'll be able to solve most of the questions, almost 90 questions. If you're able to solve more questions, you really understand it. Okay, so question number 2. Calculate the concentration in moles per dm cube. So it means we are asked to calculate for C of, we are given grams, 8 grams, okay, of sodium hydroxide dissolved in volume. Our volume is 500 centimeters, 500 centimeters cube, which is the same as 500 divided by 1000, which is equal to 0.5 dm cube. It's the same thing. 1 2 3, 1 2 3, and listen, you can punch it on the calculator to get your answer easily. Okay, then mass is given. You see, if you use C is equal to N over V, it will be difficult for you. You can solve it, but it would be difficult. You have to go through some steps in order to get it. I'm going to use that method to help you solve it. Okay, so basically we have this, we have our volume, but we don't know N. We don't know N. We don't know N. So, but in the question, we're given N to be 23, O to be 16, H to be 1. Okay, then I can use this formula. Molar mass is equal to mass over N, because mass was also given, correct? So I can make n the subject, and I will get small m over capital M. So I can use this to find the mole. After finding the mole, then I will substitute in C to get my answer. So after this, I will show you the easy method, that the formula that we wrote earlier, which is M is equal to CV capital M. This is easy, but you can do it in two ways, whether using this and that or using this formula straightforward. I just want you to understand the concept and understand how you go about the question. That is why I'm using the two. Yes. So I can calculate for the molar mass. We know how to calculate for the molar mass in terms of its mass number given NaOH, which is equal to sodium. Sodium is 23 plus oxygen 16 plus 1. So total, you are going to get 40 grams per mole. That is the unit. 23 plus this, which is 39 plus 1, 40. Okay. So after getting this, we know that N is equal to mass over molar mass. So let me use it here. Mass, I have 8 over 40. So you are going to get 0.2 mole. You can punch it on the calculator. Okay, since you've gotten our mole, I can write straightforward N over V. So when you are representing your work, you can, don't bring this one. This is how you have to do it, because representing your work is also very important. You don't write your formulas anyhow. You don't misarrange it anyhow. Okay, so this mole, which is 0.2 divided by this, which is 0.5, and 0.5, 0.4 mole dm cube. That is the answer. Or you can choose to use this formula. The second formula, roots, you can choose to use that one. This is easy. Mass is equal to CVM. So this one, we're given our mass to be 8 grams. We've calculated for the volume. Volume, you are going to do this, the same thing, and you get 0.5 dm cube. Then molar mass NaOH, you will do the same thing, and you get 40 grams per mole. Okay, then based on that, we have to find concentration. So the formula, you put your 8 grams here. 8 is equal to C, we don't know, times the volume, which is what? 0.5, times our molar mass, which is 40. So after getting this, you will divide both sides by 0.5 times 40, C times 0.5 times 40, all divided by 0.5 times 40. This will cancel that, and we have our C to be equal to this. When you do the calculation, you're going to get the same thing as 0.4 mole dm cube. So therefore, our C is equal to 0.4 mole dm cube. From this one, this is also correct. Or from this, you can just make C the subject. C is equal to mass over Vm. Then you substitute in. If you substitute, you are going to get the same thing. 8 over 0.5, that is the volume, times the molar mass 40, is the same thing. So using this or that, you are going to get the same answer. Okay, that is more concept. Let's move to the next question, which is question number 4. You see, basically this, we are calculating for the concentration. Sometimes they can ask you to calculate for mass when concentration is given, volume is given and molar mass is given. Yes. They can also frame the question. Once you are calculating for concentration, they can also ask you to find for mass. They can also ask to find for the molar mass. They can also ask to find for the volume. That is change of subject. So you have to obey the formula, this, this, and that. The other formula that I wrote, which is the molar mass. Okay, that is that. That is that. You are going to get the same thing. Okay, let's go to question. Is it question number? Okay. We are moving to question number 3. Calculate mass of sodium chloride in 200 centimeters cube of 0.5 mole dm cubes of sodium chloride. Sodium chloride is a common salt. So I have my C to be 0.5 mole. Volume, you know that our volume, we're given 200 centimeters cube, which is the same as 200 over 1000. And we're going to get 0.2 dm cube. Perfect. Okay. Mass. But we know from the formula, mass is equal to CVM. Using this formula, we know our concentration, we know our volume, we can calculate for the molar mass. So molar mass for sodium chloride, NaCl, we are going to have 23 plus chlorine, which is 35.5. So I'm going to have, but bear in mind, we solved this before. If here was 2, I would have gotten 35.5 plus 35.5 or 35.5 all into bracket times 2 or 2 times 35.5. Okay. So this, we are going to have 58.5 grams grams per mole. Okay. Then I can find my mass. M is equal to C, which is 0.5 times V, which is 0.2. Then molar mass 58.5. So total, you are going to get 5.85 grams. This is the easiest one. If you don't want it, you can apply the other one. Or, you see, we have our concentration, volume, and we are asked to calculate for the mass. So you can use this. We know that mass is equal to molar mass times N. That is the formula. This is from, it was from molar mass is equal to N over mass over N. So we make M the subject, we're going to get mass is equal to Mn. That is it. But you can calculate for the molar mass. Assuming you've calculated for the molar mass, you have our molar mass here. This by the mole, it's difficult for you to solve it. Before you solve the mass, you have to go and find for your mole. So our mole amount of substance, N, which is amount of substance. So amount of substance N is equal to, we also know another formula, molar mass. We know C is equal to N over V. So from this implies that my N is equal to CV. So you can use this one to find for the concentration. We find for the mole, the amount of substance. You know that our C is 0.5 and this is 0.2, and 0 times that, you are going to get 1 sorry, 0.1 mole. Yes, 0.1 mole. Because this time that you are going to get 10. How many decimal places? 2. So 1, 2. So you can punch it on the calculator to get your answer. After getting this, right now I've gotten my mole. Then I can use this formula. Mass is equal to m, and which is equal to molar mass 5. Molar mass 58.5 times mole, which is 0.1. You punch this on the calculator and you are going to get 5.85 grams. Easy. So it is very important to take this formula into consideration, or take it very serious. Okay, the last question, and then we move to the second concentration, which is the mass concentration. Question 4, amount of 0.25 grams of aspirin. So we're given our mass to be 0.25 grams. Okay, the aspirin is C9H8O4. It's contained in 100 centimeters cube. So our volume was also given 100 centimeters cube, which is the same as 100 over 1000, 0.1 dm cube. Okay, how many moles and how many molecules of aspirin? So this means that they are telling us to find amount of substance, which is N1. Then also how many molecules, capital N, that is number of entities. How many molecules? Then we are referring to number of entities. And we know the number of entities is small n times capital L. We are asked to find this. Okay. Of aspirin. So, and how many molecules of aspirin are in 1 dm cube of solution? Okay, so the N, they are telling us to find how many molecules of aspirin are in 1.00 d of 1 dm cube. That is 1.00 dm cube. Okay, so that is that always it dissolves in 1 dm cube of a solution. Okay, so first of all, we are asked to find the N. So I know my concentration is equal to N over V. I know my V, but I don't know N. I don't know my concentration too. So this type of question, you can apply the other one, which is M is equal to CVN. Yes, because you can calculate for your molar mass. Molar mass, let me indicate C to be, we know the carbon is 12, hydrogen is 1, oxygen is 16. Okay, so yes, I can calculate for the molar mass. Molar mass of C9H8 and O4. Okay, so 9 times 12 plus 8 times 1 plus 4 times 16. 180 grams per mole. Okay, once I've gotten this, mass was given, V was given, so mole, per the mole, we are asked to find mole. A mole from this, C is equal to N over V. N is equal to CV. Yes, N is equal to CV. Okay, so mass concentration, my mass is equal to 0 point, we asked, so we calculate for the C. From this, I can make my concentration the subject. So C is equal to C is equal to V. C is equal to M over CV. Okay. So I have my mass 0.2 divided by concentration. Oh, capital M, sorry, capital M. So 0.2 molar mass 180 and the volume which is 0.1. So when we are done, we can calculate for the mole. We know that C is equal to N over V. So our N is equal to CV. So we know the volume. We know the concentration. The concentration is 0.0139. Yes. But the volume given, this volume here is different from this volume because per the concentration given, the mole is in 1 dm cube. So if it is 1 dm cube, then our volume is going to be 1. That is it. So you're going to get the same thing, 0.0139 mole. Yes, because when you consider this, the concentration in general, concentration is mole over volume. So the mole per dm, 1 dm cube. So you are going to get this. Yes, that is that. So when you get your number of moles in, because here, how many molecules of aspirant are in 1.00 dm cube? 1. So that is, it means that the mole here is N, the mole here, the volume is 1 dm cube. So after getting this is over 1 dm cube, 0.0139 mole over 1 dm cube. So you are going to get something like this. The same thing here. When you are done, you calculate for your N. So N is equal to, capital N is equal to small n times L. We know that this, you are going to get 0.0139 times Avogadro's constant, 6.02 times 10 raised to the power 23. You punch it on the calculator and you get your answer. After getting it, then you include molecules of aspirin. So, okay, 0.37 times 10 raised to the power 21 molecules of aspirin. Okay, so that is the final answer. That is cool. So we are moving on to mass concentration. B Let me write the questions and we will start solving it. Okay, so after these questions, we are done under mass concentration. Mass concentration. Mass concentration. Okay. Mass concentration, it is a, so we have two types of concentration. I said it, mole concentration and mass concentration. It is the mass of a substance in grams dissolved in 1 dm cube of solution. For the mole concentration, it is the mole of a substance, or is the amount of substance in moles dissolved in 1 dm cube of a solution. So it is also called mass density or density. In physics, we know that density, that is, this symbol is called rho. It's called rho. So mass over volume is the same thing as mass concentration. But the thing is, in physics, density that we know, our unit for the mass is kilogram, and the volume is meters cube. Mass kilogram, the unit is kilogram, and the unit for volume is meters cube. Over here, our unit is grams, and our volume is dm cube under the density, under the mass density or density or mass concentration. We have this unit. So in more concept, we use grams per dm cube because we are, you see, the substance that we are dealing with is very small. Is very small because when we are preparing chemicals, the solute that we need and the solvent that we need to form the solution, the gram is very small, and the liquid, you see, we measure it in grams. That is why. But for the volume, it's always dm cube. But the mass, the reason why this, the unit is very small, grams and kilogram, grams is very small than the kilogram because 1,000 grams will give you 1 kilogram. But in the density aspect of physics, we are measuring big objects. Like if you want to know the density of metals, if you don't want to know the density of a ship. So basically, in physics, we use more of the SI unit than that of chemistry. So take note of that. It has a unit gram per mole because gram per mole, a gram per dm cube. I did a mistake. It's gram per dm cube. Gram per dm cube. Gram per dm cube or gram. Yes, it's very important. Okay, so it is also called mass density or density. It's the same thing, and it has the same formula here, just that the unit are different. Okay, it has a unit gram per dm cube or gram per dm cube, the same thing. So the formula that we are going to use here is a general formula for mass concentration, and this formula, I will prove to you how we had this formula. So from this, I'll prove it before we start with the questions. Okay. From this, we know that rho is equal to mass over V. You can name it as equation 2. Then you can use the general formula, which is mass is equal to CVM. You can use this, that one, to equation 2. Then you can say putting 2 into 1. If I'm saying putting 2 into 1, it means whenever I see I've made M the subject, so I will put, in place of M, I will substitute CVM. So I have my rho is equal to mass. So right now mass is this. Mass is equal to that. So I'm putting this into that. So if I'm putting this into that, then I can put, in place of mass, I can put this one there. So I'm going to get CVM all over, I have my V there. Then mass is now CVM. Okay, you do cross multiplication. You are going to have No, you can maintain it. Then V will cancel V. V will cancel V, and we are going to get Cm. So that is the formula. Cool. So you are done proving the formula. Done proving the formula. So these are the two formulas you are going to use. Okay, so let's start. Let's start with the questions. Okay. Question number 1. Calculate the concentration in gram per dm cube of 0.75 mole dm cube of sodium carbonate solution. So you could see that 0.5 is mole dm cube. That's the concentration. So our concentration is, that is mole concentration, 0.75. Okay. Then, okay, you can use this formula. We are asked to find P, which is the mass density, because calculate the concentration of gram per dm cube. Gram per dm cube is mass concentration. So we don't know this. I can't use this formula. Using this formula is easy, but yes, using this formula is easy. Using this is very faster. So this is equal to mass density or mass concentration is equal to Cm. We can find our molar mass. Our molar mass for Na2CO3 is equal to 2 times the mass of sodium, which is 23, plus carbon is 12, plus oxygen, which is 16 times 3. So adding all, you are going to get 106 grams per mole. Okay, then we have our formula. Mass density is equal to concentration, mole concentration 0.75 times 106, and this you are going to get 79.5 grams per dm cube. grams per dm cube. That is that easy. You can also, without going through this, you can also use C, or M is equal to CV capital M. You can use this. You calculate for the molar mass. Let me see. Mass was not given. So since mass was not given, we have molar mass. We have this C. We have V. Let me see. Rho is equal to mass over V. Okay, trying to use these two will be very tough for you. So the best thing is to use this formula, and you are free to go. That is question number 1. Okay, let's move to question number 2. Calculate the value of X. We are asked to calculate for this. This compound is attached to water, hydrate. So when you see compound attached to water, after pronunciation, you are going to add hydrate. So assuming you see, if it is 3, it is tri. If it is 4, is tetra. If it is 5, penta. 6, hexa. Is it pent? Hexa. 7. So if we calculate for the value of X and we get 4, it is a tetrahydrate. That is compound attached with water, hydrate. Yes. If it is 3, trihydrate. 6, hexahydrate. 5, pentahydrate. Okay, that is that. So the this X is for hydrogen and is for oxygen. So take note of that. So calculate the value of X in calcium hydroxide X hydrate when concentration in mole dm cube is 0.1 mole dm cube and the mass of the compound is 3.65 grams in 250 centimeters cube of solution. If you want to solve this question, solve it easily, you have to jot down the data. So we know question number 2, our C is 0.1 mole dm cube. Mass is equal to 3.65 grams. Volume, which is 250 centimeters cube, and we know that the volume you must to change it to decimeter cube, 1000. So 0.25 dm cube. Okay, so we are asked to calculate for X. Before you calculate for X, you have to know the molar mass for CaOH 2X H2 is equal to, when you add everything, unless you find for the molar mass. So this type of question, before you find X, you have to find for the molar mass of this. Yes, before you can solve this problem. Because this, I can write this of the form calcium. The 2 is for only oxygen and hydrogen, but the calcium here is only 1. So I will write my calcium, which is 40 plus oxygen. So the 2 will be for oxygen and hydrogen. So I can write it 2 into bracket. Oxygen here is 1. Inside oxygen is 1. So I can write 16 plus hydrogen is also 1. Then I have plus this compound. So this compound is attached to hydrogen and oxygen. So I'm going to get X into bracket 2 times hydrogen. 2 times, how many hydrogens are there? 1. Hydrogens are here 2. So 2 times 1, which is still 2, plus oxygen, which is 16. This is how you're going to write it. But if you don't want it like that, if you don't want this like that, you can write this. This is of the form AO2 H2 XH2O, something like that. So it's 2 times oxygen. Like if I multiply 2, I'm going to get 2 times 16 plus 2 times 1. It's the same thing. Okay. Take note, the X is for the compound. It's not for only hydrogen. It's not for only oxygen. So when you are multiplying, you didn't take a X is multiplying the compound, the mass of the compound. So the X into bracket, their masses. So take note of that. So after getting this, how do you find for X? We know that this one, you are going to get 40 plus 2 times this, which is 32 plus 2, or I can even 16 plus 1, which is 17. 17 times 2, which is 34, plus this 2x plus this times that, all straightforward. I know that 2 plus 16 is what? 18. So 18x. 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 So that is that. Okay. So if I solve this, I'm going to get 74 plus 18x. So before you find for x, you have to calculate for the molar mass of calcium hydroxide X hydrate. Then when you get the value of this, you place it here, then you create it to the this and you solve for x. So after getting this, if you can choose to write it this, you can choose to write this before solving for this, or you can solve it after that, then you quote your formula, you move on. Okay, but per the formula given, I can use, once I have mass, I have volume, I have C, then I can use this formula. M is equal to CV capital M. Yes. If I make a molar mass the subject, I'm going to get molar mass is equal to mass over CV. That is, I divided both sides by CV, CV. So CV will cancel CV here, and I'll get mass over CV. And if this is equal to that, this is also equal to that, like this. So it's easy. My mass is 3.65 divided by the concentration, which is 0.1, times the volume, which is 0.25. You punch it on the calculator. Then when you punch it on the calculator, you're going to get 146 grams per mole. Okay, so after getting your molar mass, then let me clean this. After getting your molar mass, then this, the one that I've calculated, is the same as this. So I can say therefore 146 is equal to 74 plus 18x. Yes, this is another way to find for your molar mass. We've been given this, so you can use this one to also find the molar mass. Because we are asked to find x, there's no way, if you don't find the molar mass, we can never solve this problem. So when you find for your molar mass, you substitute, because this is the same as this is the same as that, this is also a molar mass, this is also a molar mass, so they are the same. So you are going to have 146 minus 74 is equal to 18x. So when you subtract this, 72 is equal to 18x. You divide both sides by 18, both sides by 18. So x is equal to 4. So therefore, x is equal to 4. So if it is 4, if I put there, then I'm going to get calcium hydroxide tetrahydrate. Yes, so we are done. Cool question. Okay, so let's go to question number 3, then we're on that. So if you find any problem, you can write it on the comment section, and I will explain it to you under the comment section. Question number 3. You are given sodium carbonate X hydrate solution in which 107.25 grams of the salt is dissolved in 500 centimeters cube solution. The concentration is 0.7 mole dm cube. Calculate the concentration in gram per dm cube. So C, mass was given to be 107.25 grams. Volume, V is equal to 500 centimeters cube. 500 over 1000, you are going to get 0.5 dm cube. Easy. What else? 0.75 mole dm cube. So C is given to be 0.5 mole per dm cube. So we asked to calculate for the concentration. So A, the concentration in gram per dm cube. So that is this. This is the same. We have mass over V. We have our mass. Mass was given to be 107.25 divided by our volume, which is 0.5. When you do the calculations, you are going to get 214.5 grams per mole. gram per dm cube. Gram per dm cube. B, the molar mass of the compound. The molar mass of the compound. Okay, so B, molar mass. We know that this is equal to Cm. This is equal to Cm. So from this, I can make my molar mass the subject. I'm going to have this rho over C, and the concentration I've calculated for this. So 214.5 divided by the concentration, which is 0.5. A. In the question, it was 0.75. 0.75. So this and that, we are going to get 286 gram per mole. Okay, so we are done with B. Then C, the value of X. The value of X. So it's the same concept that we did. So we know that molar mass of the compound Na2CO3 XH2O subscript, if you like, don't bring it, equals, how do you calculate for this? Is 2 times sodium over the sodium is 23 plus carbon, which is 12 plus oxygen, which is 3 into bracket 16 plus X into bracket water. Hydrogen is 2 times 1, which is 2 plus oxygen 16. Yes, but we know that we've calculated for this molar mass the same thing here. If you like, don't bring. So we are going to have 286 is equal to, this will give you 46 plus 12 plus this will give you 32 will give you 40 will give you 48 plus 2 plus 16, which is 18x. 18x, you group like terms and you solve for x. All these values, this one, you can group like terms. When you group like terms, when you solve for x, x will be equal to 10. So you can check it out. Then you solve for your x. This is a cool question. We are done for mass concentration. We are moving on to the next topic. Okay, so when we talk about mole fraction, then we are talking about the ratio of mole of a substance to the total number of moles of all components of a solution mixture. So what is it means is that if you want to find a mole fraction of a mixture, then it will be the mole of that mixture over the total mole of the mixtures. Okay, so two, given a substance, we are dealing with two substances. It can be many. Okay, so given substances A and B in a solution mixture, mole of A is represented by a number of A. Yes, that is Na. You can also choose to write it Na. That is mole of A accepted. Or this mole of B is Nb. Okay. Therefore, the mole fraction of A represented by Xa is equal to Na over the mole of the two. So what it means is that if I want to find we represent Xa to be the mole fraction. So Xb will be the mole fraction of mixture B, and this is mole fraction of mixture A. Okay, so if you want to find the mole fraction of A, then it will be its mole over the total mole, which is Na plus Nb. It's the same thing for B. For B, we can for B is Xb is equal to Nb over Na plus Nb. If you are dealing with, let's say, three mixtures B, C, then mole fraction of A is equal to Na all over Na plus Nb plus Nc. That is it. And for Xc, you are going to get the same thing. Nc over Na plus Nb plus Nc. That is the properties of mole concept, the mole fraction. Okay, so let's move on. Then three, since we are dealing with fractions, we are dealing with ratio. Mole fraction is the ratio of moles. So therefore, it has no unit. You are not going to get any unit because we are dealing with ratio. When there is a ratio, there's a cancellation of unit. So there will be no unit. Okay, let's move to the question. Calculate the mole fraction of 8 grams of oxygen mixed with 11 grams of carbon 4 oxide. Carbon 4 oxide is the same as carbon dioxide. It is the same as CO2. So this is what we are going to do. How many compound here? We have 3 compound or substances. We have of oxygen. We have oxygen. Oxygen exists as a gas, which is O2. So we have oxygen gas mixed with 11 grams of carbon 4 oxide, that is CO2, and 3.5 grams of N2, which is nitrogen gas. So we have 3 substances. We have 3 substances here. So first of all, in order to calculate for the mole, we're given the mass of individual elements. So in order to solve it, we can use this formula. Molar mass is equal to mass over N. Molar mass. So you can make N the subject. From here, you can make N the subject. This implies N is equal to mass over capital M. Yes. So I know that 8 grams is for oxygen, 11 grams is for carbon dioxide, and 3.5 grams is for nitrogen. Okay, so I know X, the mole fraction. Let me calculate for the molar mass. So I know mass of oxygen gas is we are given to be 8 grams. So 8 molar mass for oxygen will be equal to 2 times oxygen, and oxygen is 16. So we are going to have 2 times 16, which is 32 grams per mole. Okay, so X of oxygen, X of oxygen gas will be equal to, okay, let me maintain this one. Then I'll calculate for carbon dioxide, mass of carbon dioxide, CO2 is given as 11 grams. So 11 grams. So the molar mass for carbon dioxide is equal to carbon. We have 12. 12 plus oxygen. Oxygen is 2 here. So 2 times 16. And you are going to get 2 times 60, which is 32. 32 plus 12, which is 40 grams per mole. Okay. Mass of nitrogen gas, which is N2, and it was given to be 3.5 grams. The reason why we are doing all these things is that in mole fraction, we are talking about mole. We are not talking about mass or molar mass. So you have to convert everything. You convert it to mole. You solve it in a mole form. Yes. Then molar mass for N2 is equal to 2 into bracket. Nitrogen is 2 here, 14. So which is 28 grams per mole. Okay, so in order to get the mole of oxygen, O2, is equal to, so you can choose to represent it with any variable. Oxygen 2 to be a mixture A, CO2 to be a mixture B, NO2 to be a N2 to be a mixture C, but I'm using their compound. So we are going to get from this mass, so 8 over 32, and you are going to get 0.25 mole. Okay, so N of CO2, we will get 11 over 40, which is also equal to 0.25 mole, the same. Then N, capital N2, nitrogen gas, will be 3.5 all over 28, which is also equal to 0.125 mole. Okay, so we've gotten the mole of oxygen, mole of carbon dioxide, mole of nitrogen gas. So that is that. We've gotten that. So we can calculate for the one that we were asked, the molar, the mole fraction for the compound. Calculate the mole fraction of 8 grams of oxygen mixed with. So it means that before you solve it, first of all, you have to calculate for the mole of each of the mixtures in the compound. But we are asked to calculate for the mole fraction for oxygen. So mole fraction of oxygen is this as gas. Oxygen gas is X oxygen gas is equal to the NO2 of the oxygen over the total NO2 oxygen gas plus mole of carbon dioxide plus mole of nitrogen gas. Okay, so oxygen, we have 0.25 divided by 0.25 plus 0.25 plus 0.125, and the total we are going to get 0.24. So no unit, because we are dealing with ratio of, because if I add, or I'm going to get mole, this one to mole will cancel mole. So that is it. That is easy. They can also ask you to calculate for the mole fraction of maybe oxygen and carbon dioxide. So if it was carbon dioxide, we are going to get X CO2 is equal to, yes, N CO2, mole of oxygen gas, carbon dioxide over mole of oxygen gas plus mole of carbon dioxide plus mole of nitrogen gas. So we are going to get 0.25 divided by 0.25 plus 0.25 plus 0.125. Because they have the same mole, carbon dioxide and oxygen have the same mole, they are going to have the same mole ratio. Yes. But the other one, it was different. So you are going to get different ratio. So that is how we solve for mole fraction. Very cool and easy. We are dealing with mole, so everything you convert everything to mole, you solve it based on the formula that you've done so far. Then okay, so there are a lot of questions they can ask, ask you on the mole concept. So just that you have to get the understanding. There are lots. I can answer 50 questions on the mole concept and mole fraction, but because of there are a lot of questions, so the understanding is very important. So we are moving to the next topic, concept of solution. Concept of solution. Concept of solution. Concept of solution. Okay, so concept of solution, we discussed solution earlier. A solution is a uniform mixture of solute and solvent. So solution is a homogeneous mixture of two or more substances. It means solution is a uniform mixture of two or more substances. The same thing. Over here, there's a key point that we need to take note of, that when we are dealing with solution. Okay, so standard solution, most of the solution, you have standard solution. How do you prepare standard solution? From this, we talk about standard solution, how to prepare standard solution. It has a procedure you need to follow to prepare standard solution. And the solution that we are going to prepare, it is based on the formula that we discussed before. Okay, so a standard solution is a solution whose concentration is known. Yes. So it's a solution of known concentration. Yes. If you see any solution with known concentration, then it is standard. And mostly it is being prepared by volumetric flask. Yes, we use volumetric flask. It's a standard uh, flask. Yes. So sometimes they can ask what's the uses of volumetric flask. It is used to measure standard or specific solution. There's another point here: concentrated solutions bought from for use in the laboratory, from which diluted solution are prepared, are called stock solutions. So when we talk about stock solution, it's a solution bought from store, and those stock solutions we use at the lab, sometimes in school, science lab, chemistry lab, we'll be using those things. So that is stock solution. That's a standard solution. Yes, when you bring it to the lab, then you dilute it. The more the concentration reduces. So that is, we have dilution factor. Dilution factor is the number of times the volume of a more concentration solution is diluted. So concentration, if you dilute the concentration, it becomes diluted, very weak. And this concept, since we are dealing with solution and we are dealing with concentration, we are going to talk about this. And this formula is very important because I'm going to show you how we are going to use the formula here. But in your practical, for your chemistry practical, this formula is very important. And this formula, we derive it from C is equal to N over V. So when you make N the subject, you are going to get CV. Yes. So when you are comparing two substances in your practical, chemistry practical, during your exams or WASSCE or whatever, you are going to use this. And the mole, we are going to use acid and base. That is titration, acid and base, acid and base. Then you do calculations based on the formula that you've done so far. Yes. How do you perform the experiment, or you perform the experiment to get your values? After getting your values, basically you are going to use this formula, and this is how you're going to do it. If the mole, assuming this is the mole of acid, volume of acid, mole of acid, and after making N the subject, you are going to get Na, Va, CAVA. For base, B, we know that NB is equal to CBVB. So according to mole concept, the mole of the acid is the same as the mole of the base. So Na is equal to NB. So therefore, I can say CAVA is equal to CBVB. So these are the formula you are going to use under practical, and also calculation aspect, you use it. When they give you the concentration of acid, concentration of volume, concentration of acid, volume of acid, concentration of the base, and they ask you to calculate for the volume of the base, you just substitute in and make V be the subject, that's the volume of the base. It's the same concept that we are going to do here. So this is what I'm discussing here. What I wrote here is the same thing here. It's the same thing here. So over here, using this formula, it's the same concept. The concentration of the concentrated solution and the volume of the concentrated solution is equal to the concentration of diluted solution times the concentration of the volume of diluted solution. What it means is that if you calculate for the mole of this, you are going to get the same thing, like the concept I'm saying here. So this is C conc, N conc, V conc. I have my C diluted, N diluted, V or di. So if I make N D the subject, and this one will be N conc, C conc, sorry, N conc. So this is equal to that. So it's the same thing, the same concept here. So since N of this are the same, this is equal to that based on what we've done there, the same concept. But notice it's real that volume of diluted solution is equal to the volume of concentrated solution plus water, because the one diluted, the one that you diluted, assuming I have something like this, and this is the concentrated volume of the concentrated solution. When I add more water, it means I'm diluting it. So when you dilute it, you see that this volume is going to be V del, and V diluted solution or volume of the diluted solution will be equal to the concentrated volume of the concentrated solution plus the water that you added. So that is that. And this is what you are going to do. Cool question. So first question, we are going to solve it. Then we'll move forward. So 25 centimeters cube of 2 mole dm cube solution is diluted to 500 centimeters. Okay, so 25 centimeters cube of 2 mole of this calcium carbonate solution is diluted. So this will become the volume of the concentrated solution. And that one is 25 centimeters cube, comma, and the concentration of concentrated solution is 2 mole dm cube. Okay, it was diluted. The V of diluted solution is 500. So the concentration of diluted solution, we have to find for this. We don't know. So you quote your formula, then you substitute in. So C conc times V conc is equal to C di times V di as subscript. Write it well. It's supposed to be So I know this is 2. I have my volume 25 and it's equal to, I don't know, the C di and times 500. The reason why we are using the same volume is because this is centimeter, this is also centimeters, so I don't have any problem. But if one is centimeters and one is decimeters, then you have to convert the centimeters to decimeters, or you have to convert the decimeters to centimeters so that they will have the same unit. If they have the same unit, I don't have any problem. But if they don't have one, you have to convert one of the unit to look the same or to have the same unit. So after this, you divide both side by 500 is equal to 500. 500 will cancel 500, and you are going to get C del dial. So you get 0.1. When you divide this by that, we are going to get 0.1. Therefore, C dial, or concentration of diluted solution, is equal to 0.1 mole dm cube. So that is that. Let's try another question so that you'll be familiar with it. Okay, so I have my solution. I have the question here. What is the volume of 50 mole dm cube of H2SO4 solution should be diluted? So this means that we are asked to find for volume of concentrated. We don't know, but the volume of diluted is 1 dm cube. Yes. In order to make, so this means that we are given concentration of concentrated solution to be 15 mole dm cube. Okay. Then concentration of diluted solution is also given as 0.1 mole dm cube. So from this, we know that C conc V conc is equal to C di V di diluted. So 15 V conc is equal to, we have 0.1, then this is 1. So you divide both sides by 15, both sides by 15. So V conc is equal to 0.00666, which is approximately 0.67 dm cube. Yes, because we're given 1 dm cube. So our answer, it has to have the same, it must have the same unit, dm cube, dm cube, dm cube. So the volume is dm cube. So we're going to get that. That is easy. We have a lot of questions there, and you can't solve all the questions. So that is that. So we are moving to the next topic. Our last topic. Preparation of standard solutions. Okay, so I will take a question and I will explain. Describe how you prepared a 250 solution of Na2CO3 with concentration 0.10 mole dm cube in the lab. Okay, that is cool. So, how to prepare a standard solution? We said a standard solution is a solution whose concentration is known. So we are also going to prepare a standard solution with known concentration, a standard solution. So when we prepare the standard solution, we are going to get concentration known. So how do you prepare a standard solution at the lab? So we are asked to describe how you prepared a 250 centimeters cube solution of sodium carbonate with concentration 0.10 mole dm cube in the lab. And most of the times, under the preparation of standard solution, these are the type of question they bring. They are going to bring similar. When I'm done with this, any question that they will give you are going to go the same procedure and everything. Sodium carbonate is a solute. It's a solute and we are going to prepare a solution. So first of all, we have to get our water and our sodium carbonate, which is the solute. So this is our solute. Our solvent is going to be water. Sodium carbonate is the solute and the water will be our solvent. So what do you do? First, you have to measure the mass of the solute, which is you have to measure the mass. You need to measure one measure the mass of the Na2CO3, which is our solute. You measure it in a beaker. So measure the mass of Na2CO3, which is sodium carbonate, in a beaker. After measuring it, you record the mass. When you record the mass, then you add a little water in a beaker for it to dissolve. And the water that we are going to add is distilled water. Distilled water. So you add distilled water in the beaker. So this type of question, first of all, I have to calculate for my mass. When I calculate the mass with